So we're going to talk about transformations, and this is going to be our next section. So it's going to be test number 12, and the information will be found in chapter 9 in your test book, in your textbook. So what we're going to talk about is transformations, and a transformation is a function or a mapping that changes a figure's size, shape, or position. And so it includes several different um, shifts. Okay, but today we're going to start with rigid transformations. And rigid transformations, a figure maintains its size and shape, and they include the translation, reflection, and rotation. So if you notice, this is a flip, so this would be a reflection, and this is a slide, so this would be a translation, and this is a turn, so it would be a rotation. Okay, so those are the rigid transformations. Okay, the first one we're going to talk about is the translation, which we said slide is the best term for that. Is that it just kind of slides along the coordinate plane from one position to the other. So if you look right here, you notice that this triangle ABC slides and becomes triangle A prime, B prime, and C prime. So when we notate it, we want to do it with a capital T, and then down here we're going to say plus or minus x, comma, plus or minus y, and I'm going to show you in just a second exactly how we do that. When we translate or when we slide, we actually want to do one coordinate at a time. So you may have seen it this way before, where you had A, and A looks like it is at, let's see, where's the 0? Here's 0, so 1, 2, 3, 1, 2, so it looks like it's at 3, comma, 2, and then it's going to be translated, and then it becomes, if we look at this, it's negative 2, 1, 2, 3, 4, so it becomes negative 2, 4. So the question is, what exactly happened to get from 3 to negative 2? So we start at 3 and we actually subtract 1, 2, 3, 4, 5. So if we said that this was x comma y, then what we did to x was we actually subtracted 5 to get to the new position. And then I look at y, and it's at 2. And so in order to get to 4, I actually added 2. So we would say y plus 2. And this is generally what we see in middle school, and this kind of gives us the rule for what exactly happens to each a to get to a prime, what happens to b to get to b prime. When we write that in our notation, however, we would say that we had capital T, and we have a little arrow side here, and it would say minus 5, comma, 2. So we wouldn't put plus 2 because it's assumed that it's positive. And then we would say triangle, and we started with triangle A, B, C. Okay? Now it became, or it mapped to A prime, B prime, and C prime. But this up here is the notation in which we use to notate what's going on. Okay? Now if I ask what the rule is, well, the rule for this particular translation is going to be x comma y becomes x minus 5 comma y plus 2. Okay, so we got a couple of things going on. So notation is going to be here, right? And the rule is going to be here, okay? And remember that these are rigid transformations, so every coordinate in ABC, A prime, B prime, and C prime, need to follow the same rule in order to be translated, okay? So if we look at this one, we're going to translate 2, 3, negative 3. So actually what's going to happen is x comma y is going to become, in this translation, and a lot of times we write what's going on above it, so it's 2 comma negative 3 is going to become x plus 2 and then y minus 3. Okay, so we'll do that for each of the points. So we'd say m, and so if we look at m, what are the points currently for m? And it looks like this is 0 right here. So m is at negative 2, 1, 2, 3, 4. So that's negative 2 comma 4. And then we'll say n is actually at negative 3, 1. And O is sitting at 0, negative 1. Okay, so once we complete this translation for each of the points, m prime will actually be at, or add 2, right, to negative 2, so that'd be at 0, and then subtract 3, so that gives me 1. N prime, okay, so we've negative 3, we're going to add to that, that gives me negative 1. And then 1 minus 3 will give me negative 2. And then O prime would give me 0 plus 2 is 2. And then negative 1 minus 3 will give me negative 4. So these will be my new points. Okay, so go over here and I'll say M prime is 0, 1. So 0, 1. So that's going to be M prime. N is negative, oh wait, that's not 0, 1. Sorry, I moved over. This is 0 right here, so 0, 1 is right there. Okay, and then n is, let's see, negative 1, negative 2. So it looks like n is going to be right there. And let's see, we're going to go 1, 2, 1, 2, 3, and one more, be about right there. It's going to be O prime. So those would be the approximate coordinates, or the approximate locations. The coordinates are not approximate, but the graphing, because we don't have a negative 4, is somewhat approximate. So, and that gives us our new translated figure right here. Oops, if I can grab it, we can maybe make it a different color so we can kind of see better what it looks like. Okay. For the second example, we actually have the mapping, and we just need to write the rules. So we start with A, and A is at 2, 1, 2, so we'll say 2 comma 2, and then A prime is at negative 6, negative 5. Okay, so we want to, so the question is, what is the translation for this one? And to get from 2 to negative 6, it looks like we have x minus 8. And to get from 2 to negative 5, it looks like we have y minus 7. So we'll say xy becomes x minus 8, y minus 7, and then our notation for that would be capital T, and then we'd have these little side arrows, and it would be just negative 8, comma, negative 7. Okay, so on Google Classroom, you have a worksheet that's actually called Translations. So as soon as you get your chart filled in for translations from the information from the video, go ahead and start the worksheet. I do think you should probably do odds or evens, either one, just so that you can skip around and get varied practice. And we will check it in class together.